What if Earth had no sun, no warmth, no dawn, just endless night? Now imagine a planet like that, drifting alone through the galaxy. No orbit, no light, no star, just silence. These are rogue planets, world-sized bodies that don't belong to any solar system. They don't orbit stars. They wander, alone. And here's the strange part. They might be the most common kind of planet in the entire galaxy. Some were born that way, in isolation, from collapsed clouds of gas that never lit up. Others were thrown out violently by the stars that once gave them life, cast adrift by gravitational chaos. And they're invisible, almost. Cold, dark, and unlit. They don't emit light like stars, or reflect much like planets. We only spot them when they distort the light of stars behind them, like ghosts, bending light as they pass. But how many are there? Could one drift through our solar system? Could one be near us, right now? To understand them, we need to ask, what are rogue planets really made of? How do they form? And could they, somehow, harbor life in the dark? We'll follow their trail across the void, one question at a time. This is Scientific Facts, and we're just getting started. They go by many names: orphan planets, interstellar wanderers, nomads of the cosmos. But they all share one thing: they have no star. A rogue planet is a planetary mass object that doesn't orbit a star. It drifts through interstellar space, untethered, cold, and often invisible. Some were born this way, formed from collapsing gas clouds that never ignited into stars. Others were ejected from solar systems during violent gravitational battles in their infancy. Giant planets flung smaller ones out. Binary stars tore worlds apart. One misstep, and they were cast into eternal night. They're not asteroids. They're not comets. They're fully fledged planets with mass, gravity, and often atmospheres. Some may even be larger than Jupiter. Some astronomers argue whether they should even be called planets at all. After all, the classic definition requires orbiting a star. But in size, structure, and composition, they are worlds, just unanchored. And yet, we've barely seen them because they don't shine. They don't reflect enough light to spot with telescopes. Instead, they pass in front of distant stars and bend their light slightly, a cosmic ripple called gravitational microlensing. Imagine watching a distant star, and for a few seconds, its light warps and flares, as if something massive but invisible passed in front of it. That's a rogue planet. Not seen directly, but revealed by gravity itself. So how many of these invisible worlds are out there? And what are we missing in the darkness between the stars? Planets aren't born gently. In the early days of a solar system, chaos rules. Stars ignite in collapsing clouds of gas and dust. Around them, disks of debris swirl violently, slamming together, breaking apart, growing into worlds. But not all of them make it. Some planets form too close to gas giants and get flung outward like marbles off a spinning plate. Others are torn away by gravitational tug-of-war between stars and binary systems. Some are even stolen during close flybys between star systems in densely packed clusters. These are not calm ejections. They're exiles, worlds thrown from the only home they ever had. Entire orbits shift. Tidal forces rip moons away. Newborn planets collide or spiral inward. One change, and a world is lost forever. And in some rare cases, rogue planets may not be ejected at all. They may form alone, not around a star, but inside isolated pockets of cold gas and dust. Starless, silent, and self-contained. Imagine a world forming in isolation. No sunrise, no seasons, no orbit, just gravity pulling dust into shape in a place no telescope has ever seen. But how do we know this? Simulations of young solar systems often end with some planets lost to deep space, and microlensing surveys hint that there may be more rogue planets than stars. If that's true, then planet formation isn't just messy, it's wasteful. Or perhaps something else is creating them. Could there be entire populations of planets that never belong to a system at all? Could dark nurseries in the galaxy be spawning worlds that no light will ever touch? If they formed in darkness, what else about them is different? For most of history, we didn't even know they existed. Then, in 2011, something strange happened. Astronomers using gravitational microlensing, a method that detects massive objects by the way they bend light, found evidence of unbound planets drifting through the Milky Way. Not one or two, dozens. And those were just the ones we caught, by chance, during rare alignments. Microlensing only works when a rogue planet passes perfectly between a distant star and Earth. It lasts seconds. Then it's gone. Most will never be seen, even once. Extrapolate from that, and the numbers become staggering. Some studies suggest there could be as many as 2 rogue planets for every star in the galaxy. That's hundreds of billions of dark worlds, floating in silence, unseen, and almost undetectable. More planets without stars than with them. Imagine standing under a night sky where every black space between stars hides a wandering world. They don't emit light. They don't orbit stars. They don't show up in telescope surveys the way exoplanets do. But they're out there, warping starlight, lurking between systems, possibly even closer than we think. And we're just beginning to find them. The Wide Field Infrared Survey Explorer, WISE, has already found a few candidates by spotting their faint heat signatures. Future missions like the Nancy Grace Roman Space Telescope could detect many more using advanced microlensing techniques. But the truth is, we've only scratched the surface. If rogue planets outnumber stars, then most planets in the galaxy are invisible, hidden in the dark. And that raises a strange possibility. Could our solar system have once had more planets than it does now? Could one of them be out there still, drifting in silence? If that's true, how do we know one isn't passing through our galactic neighborhood right now? No sunlight, no warmth from a star, no day, no night, just an endless, frozen darkness. On the surface, a rogue planet looks like the last place life could exist. But nature doesn't always follow our rules. Even here on Earth, life has been found in places without sunlight. In deep ocean trenches, near hydrothermal vents, where heat and chemicals rise from the planet's core. Entire ecosystems survive without a single photon. Some of the strangest creatures on Earth, like Thermococcus or Halocephalobus mephisto, live in total darkness, feeding on chemicals deep beneath our feet. So what if a rogue planet had a thick atmosphere, one that trapped internal heat, or if it had a molten core, producing geothermal warmth? Some may even host subsurface oceans, kept liquid by radioactive decay or tidal heating from moons. It's not just theory. Simulations suggest that even a planet the size of Earth, ejected into space, could retain enough internal heat for billions of years, especially if wrapped in an insulating atmosphere of hydrogen or methane. Space is cold, but it's also empty. Without a star, there's nothing to warm a rogue planet, but also little to steal its heat away. These planets are sometimes called Steppenwolf planets, named after the lone wolf crossing a frozen wilderness. Silent, solitary, but not necessarily dead. If life ever began on such a world, or hitched a ride there on a meteorite, it might not need light at all. It might evolve in the dark, feed off chemicals, thrive in isolation. And if a civilization evolved in such a place, shaped by darkness, by silence, would it even look outward? Or would it never know what it's missing? We may never see it, we may never hear it, but if life can exist there, then the rules of habitability change forever. And if these planets are everywhere, hundreds of billions of them, how many are not just drifting, but living? It sounds like science fiction, a dark planet entering our solar system, silent and unannounced, but it's not impossible. The galaxy is in constant motion. Stars drift, systems shift, and rogue planets don't just float randomly. They follow gravitational paths carved by galactic tides and past encounters. Sooner or later, one could come close. In fact, something already did. About 70,000 years ago, when early humans were just beginning to spread across the globe, a small binary star system called Schultz's star passed within 0.8 light-years of the Sun. That's closer than the Oort cloud, where trillions of icy bodies orbit at the edge of our solar system, and that star may have brought its own planets with it. It didn't do much, as far as we know, but it proves these close encounters happen, and that we rarely notice them until long after they've passed. If a rogue planet were to pass through the Oort cloud, it could disturb comets and asteroids, sending them inward on long, slow collisions with Earth. The effects wouldn't be instant, but centuries later, we might see the result. And what if it came even closer? If it passed near the outer planets, it could distort their orbits. If it moved deeper in, tides, resonances, and chaos would ripple through the solar system. Earth's path could shift. Moons might be torn away. The odds are low, but not zero. And we may not know it's coming until it's too late. It wouldn't blaze like a comet or shine like a star. It would erase them, a moving shadow, blotting out the light behind it. A hole in the sky. Would we notice? Or would the first sign be gravity itself? Pulling, bending, whispering of something enormous and unseen. And if gravity speaks before light, are we already being warned? Finding a planet without a star is like chasing a shadow in the dark. They don't emit light, they don't reflect much, and most are colder than frozen nitrogen. So how do we know they're even there? Right now, our best tool is gravitational microlensing. When a rogue planet briefly passes in front of a distant star and bends its light, the effect lasts seconds. It can't be predicted, and once it's gone, it's gone. Each discovery is a cosmic accident, a perfect alignment in the right second from the right place on Earth. Most pass unnoticed. Most never return. But it works. That's how astronomers discovered the first solid evidence of rogue planets in 2011, and more since. We've also started looking in infrared. Rogue planets may not shine, but some still give off faint heat, enough for infrared eyes to spot the afterglow of their formation. NASA's WISE telescope, the Wide Field Infrared Survey Explorer, has picked up hints of massive objects that don't seem to belong to any known system. And soon, we'll have something better. The Nancy Grace Roman Space Telescope, launching in the coming years, will scan wide areas of the sky with extreme sensitivity, increasing our chances of catching these brief lensing events. And with enough detections, we can finally begin to estimate how common they really are. But the dream is more than just numbers. What if we could find one close enough to study? A rogue planet passing near our solar system, warm enough to glow faintly in infrared, still cooling from its ancient birth. Could we map it? Could we send a probe? A world without a sunrise, glimpsed for the first time by human eyes. A mission through the dark, chasing a planet that never had a home. In a galaxy full of ghosts, maybe the only way forward is to wait and watch for their gravity to whisper again. They are the loneliest worlds we know. No stars to circle, no light to grow by, no seasons, no days, just drifting for billions of years through cold, empty space. Some were born alone, some were cast out, and some may still remember the warmth of a sun they lost long ago. We call them rogue planets, but they are not rare. They may be the most common type of planet in the galaxy, more than gas giants, more than super Earths, more than the ones we know how to find. We've never walked on one. We've never seen one up close. But somewhere out there, a world the size of Earth could be moving silently through space, with oceans beneath ice, with chemistry we've never imagined, with life that never needed light. And if that's possible, if entire biospheres can bloom in darkness, then maybe we've misunderstood what it means to be habitable. Maybe we've misunderstood what it means to be alone. Rogue planets will never light the sky, but they bend it, they shape it. And someday, maybe, they'll answer back. If this journey shifted your sense of what a planet can be, like the video, subscribe if you haven't, and stay curious, because the universe still hides more in the dark than it shows in the light. Only on Scientific Facts.